Welcome to yet another lecture on power generation and economics. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Degree Engineering College, Electrical Engineering Department. So, we have seen that the different factors which are related to the economic power generation and how those factors are affected in order to obtain the economic power generation. Also, we have seen that what is the load curve and how the load curve is formed in order to obtain a economic power generation or to obtain a daily load pattern or energy consumed in a day, in a month, or in a year. So today we will see that those factors, how those factors are affect the system, means how we can easily go to the solution. So today our topic is numerical problems related with economic power generation. So let us start with the problem. The problem said, at the end of the power distribution system, a certain feeder supplies three distribution transformers, each one supplying a group of consumers whose connected loads are as under. Transformer numbers and the loads along with the demand factors and the diversity of groups are given. For transformer 1, load is 10 kilowatt, demand factor is 0.65 and diversity group is 1.5. Now for the transformer 2, the load is 12 kilowatt, demand factor is 0.6 and diversity group is 3.5. For transformer 3, the load is 15 kilowatt, demand factor is 0.7 and diversity group is 1.5. So if the diversity factors among the transformer is 1.3, find the maximum load on the feeder. There is a feeder is given and this is the entire diagram. The transformer 1, 2 and 3 and it is connected to the consumers. So let us start the problem. Solution of the particular problem. So what is the sum of the maximum demands of customers on transformer 1? So what is the sum of the maximum demands? It is given that the load is 10 kilowatt and the demand factor is 0.65. So what is the sum of the maximum demand of customers on transformer 1? Now for transformer 1, the maximum sum of the maximum demands of customers on transformer 1 is 10 into 0.65. It will give 6.5 kilowatt. Now, it is given in this problem is that the transformer is belong to the diversity group 1.5. So, as the diversity factors among the consumer connected to the transformer number 1 is 1.5. So, the maximum demand on transformer 1 can be found. There's a maximum demand for transformer 1 can be found is the 6.5 divided by 1.5. Okay, so it is given that the value is 4.33 kilowatt. Okay, the maximum demand for the transformer 1. Now, the maximum demand on transformer 2. The maximum demand for transformer 2 can be found using the previous conception. 12 into zero point 0.6 by 3.5. 3.5. 12 into zero point 0.6 by 3.5. So it is found here. From here, 12 demand factor 0.6 and the diversity group is 3.5. So 12 into zero point 0.6 into 3.5. So what is the value that we are obtaining? Is the 2.057 kilowatt. This is for the transformer, the maximum demand. And let us take the maximum demand of transformer 3. So what is the maximum demand of transformer 3? 15 into zero point 0.7 by 1.5. 15 into 0.7 by 1.5. The value is given 7 kilowatt. So our main motto is to find the what is our main motto? Our main motto is to, if the diversity factor among the transformers is 1.3, find the maximum load on the feeder. Okay, so find the maximum load on that particular feeder. So what is the maximum load to the particular feeder when the diversity factor is 1.3? So maximum demand. So maximum demand on the feeder is, so maximum demand on feeder can be found by summing all the maximum demands of the transformer divided by the diversity factor is 1.3. So 4.33 plus 2.057 plus 7 by 1.3 by 1.3. Answer is 10.3 kilowatt. So this This is the maximum demand on feeder. So we have solved a problem. Now we will go for the next problem. Our next problem is that a generating station has the following daily load cycle. It is given the time and the load, time in hours and load in megawatt. For 0 to 6, 40 megawatt. For 6 to 10, 50 megawatt. For 10 to 12, 60 megawatt. From 12 to 16, 50 megawatt. From 16 to 20, 70 megawatt. From 20 to 24, 40 megawatt. Draw the load curve and find maximum demand. And first to find the maximum demand, second units generated per day, third average load, and the fourth is the load factor. So this type of information can we get if we know the load pattern, that is the data that we have known. So we can got the information from the, if I able to draw the load curve, we just got the information of the maximum demand, units generated per day, average load, and the load factor from a daily load curve. So our first object is to find the daily load curve. So in order to find the daily load curve, we are taking x-axis and y-axis. So the y-axis is taken as a load demand and x-axis is taken as a time in hours. So now we start drawing. We have to draw this. So how we will draw? We just start drawing. So what we have taken? We have taken two axes, y and x. So this is taken as a time in hours. This is taken as a time in hours along the x-axis, and we are taking demand in megawatt. This in the problem it is given in the megawatt, the load along y-axis. So let us take some division of part scale division is 2. It is totally dependent upon you how many scale division you can able to make it a simplified load curve. So I am taking a 2 division. It is totally upon you. You can take 2, 4 depending upon the calculations. So this is 2, 4, 6, 8, 10, 12, 24 hours in a day. I just extend it. 10, 12, 14, 16, 18, 20, 22, and say this one is 24. Okay. So taking a 2 scale division and now taking as a 10 scale division. 10, 20, 30, 40, 50, 60, 70. The scale division is totally up to you. 80. The scale division, whatever the scale division, it is totally up to you. And this is 90. So now we are starting to draw the load curve. Okay. So it is given. What is the given? Just the information that we received is that from 0 to 6, it is 40. The demand is 40 for 0 to 6. For 0 to 6, up to that, the demand is 40. We have drawn to 0 to 6, the demand is 40. Now the second one is given. From 6 to 10, the demand is 50. So for 6 to 10, the demand is 50. Means from 6 to 10, the demand is 50. Now, the second portion is given. The second portion is given from 10 to 12, demand is 60. For 10 to 12, the demand is 60. 60 for 10 to 12. 10 to 12 demand is 60. For 12 to 16, demand is 50. Again, the demand is 50. From 12 to 16 means this line, along this line. From 12 up to 16. Straight line. From 12 up to 16, the demand is 50. Now, from 16 to 20, demand is 70. From 16 to 20, demand is this 70. Now, going to 70, this one, it is from 16, it is carry up to 20. To 20. Now, from 20 to 24, the demand is 40. Now, the 20 to 24, the demand is 40, means it is come down to that line, this 40 line. It is come down from 20 to 20, it is 40 line, and it is 24. Okay, so this is the load curve. This is 24, and this is 24. So this is the load curve for a daily load pattern that we can able to draw the load curve. So our first problem is that to find the maximum demand. So from that load curve, we see that the maximum demand is at 70. The maximum demand is at 70 from the load curve. So it is first problem is to find out the maximum demand. So our maximum demand from the load curve is maximum demand is 70 megawatt. We are getting the first answer. So our second problem is units generated per day, means the area under the curve, area under that particular load curve. So what is the area? What is the area for that? What is the area? What is the area? Means this area. This area must be, it is given that it is, the first area would be 6 into 40. Okay, this is our first area. So what is our second area? Our second area is from 6 to 10. This is our second area. So what is our second area? It is 50. Area under the curve is 50 into demand is 50 and time is 4. This is 6 to 10. 10 minus 6 equal to 4, and the demand is 50. And the third area from 10 to 12, this one. So what is the area? The area is 12 minus 10, 2 into 60. 60 here, this one 60. So 60 into 2. Now our third area is this one. Our third area is this one. This one. So what is our third area? Third area is 50 into 16 minus 12, 4. Means the 50 into 4. What is our fourth area? Fourth area is this one. From 16 to 20, it is 70. So it is the 70 into 20 minus 16, 4. 70 into 4. This is our fourth area. And what is our fifth area? This portion. It is value is 40 and 24 minus 20 equal to 4. So 40 into 4. So our total area is, if I take 10 to the power 3, because it's a megawatt as a common factor, it will be 12 into 10 to the power 5, because converting megawatt into kilowatt, it is kilowatt hour. This is our energy consumed. Second portion, the units generated per day. This is our second answer. The units generated per day. This is our second portion. That how much units it is generated per day. This is our second portion. So what is our third portion? Third portion is given that average load. So what is our average load? So average load is the total load, means the units generated per day divided by the hour, total time 24. So what is our average load? Our third portion. Our third portion is the average load. It is total load generated is the 12 into 10 to the power 5 kilowatt. 12 into 10 to the power 5 kilowatt. It is divided by 24 hours a day. So it is kilowatt hour. It is kilowatt is multiplied with hour. It is called the kilowatt hour and divided by the hour. So it is 50,000 kilowatt. It is 50,000 kilowatt. Is the average load. Total energy consumed in a day divided by total number of hours in a day, that is 24. Now we will go to the fourth portion, is the load. Fourth one is the load factor. Load factor is known to us average load by maximum demand. So we will go for the fourth portion. Fourth portion is the load factor. It is average load by maximum demand. Average load is given as 50 is the maximum demand. Average load by maximum demand. So average load is given as 50,000 that we have found. And the maximum demand is given that we have already found 70 megawatt, means 70 into 10 to the power into 10 to the power 3 kilowatt. It is given as 0.714, 0.714 or 71.4% is the load factor. So whatever we have done is the load factor. So we have done that particular problem. That particular problem is done. So a particular problem, a load curve is done, and a particular problem is done. So from a load curve, we can able to draw the load curve. We can find the total daily energy consumed. We can also find the maximum demand, daily energy consumed, maximum demand, average load, and the load factor. This information can be obtained that we have learned. Now we have to do it in a mathematical problem. So today we have discussed and we have implemented how we can draw a load curve. From the load curve, we can easily able to find the maximum demand, units generated per day, average load, load factor, and also we are going through the demand factor, diversity of the groups, and the maximum demand on a feeder, and maximum demand on the transformers, along with the maximum demand on a feeder. Thank you.